This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2017 AP Calculus exam, Free Response Question BC2. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline for the information presented in this video. I'll start by reviewing the free response question and the scoring guidelines used at the AP Calculus reading. I'll present a brief general summary for student performance on this question. And then we'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors, and where appropriate, I'll present some specific scoring examples. In this problem, we're given the equations for two polar curves and their graphs. The regions R and S in the first quadrant are defined using these polar curves as boundaries. In part A, we need to find the area of the region R. In part B, there is a ray theta equal k that divides the region S into two subregions of equal area. And students were asked to write an equation involving one or more integrals whose solution gives this value of k. In part C, the function w of theta represents the distance between the points on the two polar curves. Students were asked to write an expression for w of theta and to find the average value of this function over the interval 0 to pi over 2. In part D, students were asked to find the value of theta such that w of theta equals the average value found in part C. And finally, students needed to determine if the function w of theta is increasing or decreasing at this value of theta. Part A was worth 2 points. Remember, this is a calculator active question. So 1 point for the integral, the mathematical expression, and this includes the bounds, and 1 point for the answer. Part B was worth 2 points. 1 point for an integral expression for one region, and 1 point for everything else. That is the final correct equation. Part C was worth 3 points. 1 point for a correct expression for w of theta, 1 point for the integral expression in the formula for average value, and 1 point for the average value. Part D was worth 2 points. 1 point for solving the equation w of theta equals the average value, that is, for finding a value of theta such that w of theta is equal to the average value found in part C, and 1 point for stating that w of theta is decreasing at this found value of theta, and for providing a valid reason. Here are some brief comments about student performance on this question. In part A, most students were able to use the formula for area, but some had trouble evaluating this definite integral, which suggests that these students had difficulty using technology appropriately. And some students confused the polar coordinate system with the Cartesian coordinate system. In part B, many students had trouble interpreting a region divided into two equal subregions by a ray. Some did not correctly use the additive property of integrals, and some students had trouble with area functions, using the expression associated with Cartesian coordinates, or not writing a correct expression for the area between two polar curves. In part C, many students were simply unable to write an expression for w of theta, and some students didn't understand the meaning of radial distance and the meaning of r in polar coordinates. Although most students were able to write an expression for average value, there did appear to be a lack of conceptual understanding. And in Part D, some students had trouble with technology, that is, in solving the expression W of theta is equal to W sub A. And many did not provide a correct calculus-based reason for their conclusion. The first point in Part A was for writing the correct integral expression for area. But in scoring this part, the constant 1/2 is not included in this point. For example, here the student gets the first point, even though the constant is not included. And in this question, this expression is not considered a general formula for area, since the function f is defined in the statement of the problem. In this example, the student used the actual expression for f of theta. This also receives 1 point. And here are some examples in which a non-zero constant multiple of the correct interval is included. Each receives the first point. Here are some specific interpretations regarding the first point in Part A. An indefinite integral alone does not earn the first point. However, the student is eligible for the second point if the constant 1/2 and the correct answer appear. A definite integral of r squared does not earn the first point. This is considered a general formula. However, the student could earn the second point. If a student earns the integral point, it is banked, and that means they can't lose it. And finally, if there is a missing or incorrect constant, the student cannot earn the answer point. There were some notational fluency or parentheses issues in Part A. Suppose there were missing parentheses in the integrand. Well, then it isn't clear which expression should be squared. However, in the presence of our correct answer, the student earns both points. Without our correct answer, the student does not earn either point. And point 652 was a common incorrect answer here. The second point in Part A was for the answer. Bald answers in this part, that is an answer without any supporting work, earn no points. And the only acceptable answers here were 0.648 or 15 pi minus 16 divided by 48. In Part B, the first point was for an integral expression for one of the regions. And this point was awarded for an integral expression with the correct limits, where one of the limits is k. And here are some examples. And each of these earns the first point. Here are some specific interpretations regarding the first point in Part B. An integral without one limit of k does not earn the first point. And here's a common example. This expression alone does not earn the first point. In this problem, in this part, misspellings were okay. That means a student could use an x in place of a k as a bound on a correct definite integral and still earn the first point. The integrand must be a non-zero constant multiple of the correct integral to earn the first point. And this first point, if earned, is also banked. If there are missing parentheses, the student is eligible for the first point, but cannot earn the second or the equation point. And if the student makes any algebra or simplification mistakes, they do not earn the second point. The second point in Part B was for the correct equation. And this point was awarded for a correct version of our equation, and not for some vague expression. Here are some examples in which the student would earn both points. In the third example, 0.922 is half the area of the region S. In Part C, the first point was awarded for a correct expression for W of theta. And this expression must be explicitly stated, not included in an integral expression. Here are some examples in which the student earns the first point. If there are missing parentheses or an incorrect distribution, the student does not earn this first point, And here's an example of this error. The second point in Part C was for the correct integral expression as part of the average value calculation. And the correct limits must be included here in order to earn this point. The student doesn't need to declare W of theta to earn this point. And an incorrect expression for W of theta can still earn this second point. And here are some examples. The student is still eligible for the third point, but they must get our answer. And if there is a missing or an incorrect constant, the student cannot earn the third point. The third point in Part C was for the answer, the average value. And bald answers here earn no points. And the only two acceptable answers were 0.485 or the analytical answer 14 minus 3 pi divided by 3 pi. The first point in Part D was for solving the expression W of theta equals W sub A for theta. And the acceptable answers were 0.518, which is rounded, or 0.517, which is truncated. The second point in Part D was for stating that the function W was decreasing with a correct reason. And here are some examples in which the student earns both points. In each case, they have conveyed the solution to the equation and provided the decreasing conclusion with a reason. Note that the student does not have to report a value of W prime to earn the second point. However, if they do report a value, it must be in this interval. If the student reports a value outside this interval, they do not earn the second point. There's one more issue in scoring Part D. If the average value point was not earned in Part C, the student may still be eligible for both points in Part D by importing their answer from C. However, they must have a correct expression for W of theta in Part C, and their average value must be between 0 and 1, and the value of theta that they find must lie in the interval 0 to pi over 2. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. And there is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.